I'm going to be talking about my drug, betotaxiel. That is the structure right underneath the name of it. Some interesting facts that I learned about this drug is it is a selective beta blocker that is used to treat glaucoma. There is the beta blockers that work as a temporary medicine that can stop and reduce the body's natural fight and flight response. It may impair thinking and reactions. So off to the left, I kind of did a picture of what it would look like if that optic nerve was damaged by all that fluid that's in there. A little bit of information about glaucoma. This drug is used to treat the glaucoma. Glaucoma is a group of eye conditions that damage the optic nerve, which can create loss of vision over time. It can cause high pressure in the eye, which is why that last picture kind of showed it pretty well with that fluid that's built up in there. It helps, this drug is helping it lower that pressure inside the eye to reduce the blindness and the overall fluid into the eye. How this drug will work in action, it's taken by mouth, so it's like in a pill form. It basically will reduce the pressure in the eye when taken and prescribed. Basically it's going to help reduce that fluid buildup in the eye of the chamber as well, which will reduce that pressure overall and then overall help the optic nerve and the loss of vision. So it basically will eliminate some of those factors. Again, the picture kind of shows where it's going to be hitting if it is getting damaged to that optic nerve, and then where that pressure is going to be taken on the eye. Side effects when taking this drug, it can cause some discomfort in the eye, blurred vision, itching, swelling, eye pain, and dryness. If using the eye drops, this is rarely found, but fatigue, insomnia, nausea, dizziness, lightheadedness, depression, slow heart rate, low blood pressure, cold extremities, shortness of breath, and wheezing. Alternatives, I didn't really find any alternatives for treating glaucoma. This is a couple other recommendations that they would say that could help if the drug wasn't helping with those. So some herbal remedies, meditation, just eating and exercising, eating plenty of water, taking vitamins, European blueberry is recommended, walking and doing yoga and other recreational activities, relaxation, marijuana, acupuncture, or some other ones that they recommend. Some of the functional groups that are on my drug are, you can see the alcohol right there, the ethers, the other ones in that orange category that's circled. The ammonium salt is circled in green, and then the aromatic ring is that big purple one. This is the VSEPR molecular geometry. So mine had 3, the tetrahedral, trigonal, planar, and bent. So all those are color coded in my drug. Hydrogen bonding with water. So I do have quite a few donors that have a couple lone pairs that can be acceptors to those water molecules that are shown in my molecule. Polarity and solubility predictions. So I basically predicted, based off of the types of polarity that I could see and show, that based off the chart as well, that my drug was going to be soluble. It also was found in the Merck index that it was freely soluble in water. Protein binding sites, so these are the three. I'll kind of zoom in here. Those are all my nonpolar regions on my drug. I had quite a few with the carbon and hydrogen bonds. The ionic attraction, I was able to find one on my drug that had that ionic attraction with the plus and minus. And then the hydrogen bonding site, I was able to take one of those lone pairs and show that a protein could connect to that site on my drug. pH changes. So with the low pH, which is my ammonium salt for my functional group, it would, obviously be in its acid form. When I changed it to a higher pH, that ammonium salt was transformed into amine, which can be in the conjugate base form. I only had one that I could find on mine for the chiral carbons group. That's circled pretty dark in that middle one right there. And then some things that I found by looking at all of the information that I gathered for my drug, the molecular geometry, I was able to predict that the polarity and solubility of beta-oxyl, which I found was soluble in water. There was protein binding regions that can occur. When I changed the pH, it would affect the overall effect on the drug. And by understanding the mode of action of the drug, it can basically reduce the pressure of the damage on that optic nerve and loss of vision. A couple questions that I'm going to be quizzing people on, just to kind of recap on all the information I went over. What does a beta blocker do? A, it impairs thinking or reaction, or B, stop or reduce the body's natural fight or flight response. The next question I had is this drug soluble? A, it is soluble, or B, it's insoluble. The last question I had was, which is an alternative medicine to treat glaucoma? A is aspirin, or B, self-regulation techniques or physical exercise. Here are some of the citations I had. Just take a couple minutes to kind of gather those questions that I had. Again, those are these three. The answers to those questions, for one, it was B, that it stops or reduces the body's natural fight or flight response. For the beta blocker, in regards to what does it do. 2 is the drug soluble. This drug is soluble in water. And then for question 3, the answer is B, for which is an alternative medicine to treat glaucoma, basically to self-regulation techniques or physical exercise. And so that concludes my drug. Thanks.